Okay. Find the closest point on the line y equals 3x minus 1 to 5, 4. All right, so this one, the closest point on the line means I don't actually have to find the distance. I just have to find this point. This one is like the previous one, except I don't have to use the distance formula at the end. So let's go ahead and get started on this one. Y equals negative 1/3 x minus or plus b. Okay, now I have to plug in my x and y point. I'm given 5, 4. So let's see. This is going to be 4 equals negative 1/3 times 5 plus b. And this is not going to be a nice number. It's going to be 4 plus 5 thirds. Because negative 1/3 times 5 is negative 5 thirds. I'm going to add 5 thirds to both sides. So let me think about this for a second. 4 is just 12 thirds. 12 thirds plus 5 thirds is 17 over 3 equals b. Yuck. I already hate this one because we're going to have to deal with a not so nice value for our y-intercept. But the show must go on. So our equation is y equals negative 1/3 x plus 17 thirds. And then our original equation, which still stands, is y equals 3x minus 1. So what I've done so far is I had this original equation and I had a point not on the line. That point not on the line was 5, 4. 5, 4. So what I did was I found the perpendicular to my original line and I found the equation of that perpendicular that passes through the point not on the line, 5, 4. Now I just need to find the points where these two cross one another. And the way to do that is to figure out either x or y. Again, since these are both equal to y, it's really easy for me to rewrite this as 3x minus 1 equals, so I'm going to substitute 3x minus 1 in for y in the first one because they both equal y, equals negative 1/3 x plus 17 thirds. Let's just hope that keeping everything in thirds pays off for me. You know what I could do? Um, this is 1/3 x. I'm going to put this in parentheses so we don't mix this up. There we go. I multiply everything in this equation by 3, and I can get rid of my thirds on the bottom. I'm going to do that and see if that makes this easier. 9x minus 3 equals negative x, because I multiplied it by 3, plus 17. That looks like it's going to be a little more workable. So now I'm going to add x to both sides. That's going to give me 10x on this side and get rid of the x on the other. And I'm just going to right away add 3 to both sides as well. That gets rid of the 3 on this side and makes the other side 20, or x equals 2. And that means if x equals 2, y equals, let's see, 2 times 3 is 6, minus 1 is 5, y equals 5. So the point on the line that's closest to the point 6, 2, it's the 5, 4. I keep looking at this one. 5, 4, closest to the point 5, 4 is 2, 5. Let's see if I did that right. There it is. Okay, so again, like here are the steps. Find the equation of the line perpendicular to this equation that passes through the point that you're given. Okay, we've done that, we've done that, we've done that. So you should know how to do that. Then you need to figure out where these two lines intersect. The point of intersection can be found by setting the two equations equal to each other using substitution, or you can use the elimination technique if you prefer that from algebra. Once you've done that, that will give you the point on the line that is closest to the point that was not on the line. Okay. And then if you need to find the distance, use the distance formula to find the distance between them. Let's do one more, letter E. This one involves Mitchell. Let me just shrink this down. I'm going to need some more space here. All right, letter E. Mitchell lives on Woodland Avenue at the closest point to his school. The equation y equals 3x plus 3 can be used to represent Woodland Avenue, and I can easily find an equation perpendicular to that. His school lies at the origin. Oh, that's nice. The school bus will pick him up only if he lives farther than 2 miles from school. If each unit on the coordinate plane represents 1 mile, find the distance from his house to school. So basically, I'm finding the distance between the origin and the line 3x plus 3. And if that distance is greater than 2, he can ride the bus. If not, he has to walk. Let's figure this out. So the first thing I'm going to do is find an equation of a line perpendicular to 3x plus 3. Y equals, this is going to be negative 1/3 x plus b, okay? And then I'm going to plug in the point that I know that's not on the line, and that's going to be 0, 0. So this is going to pass to the origin. Wait a second. If it passes to the origin, what is my y-intercept? It's just 0. So actually, I don't have to worry about this step because if I plug in 0, 0, I'm going to get 0 equals b. So b is just going to be 0 because my point is on the origin. Nice. Okay, so this line is perpendicular to this line and it passes through the origin. Now I need to figure out what the point is on the original line that's closest to this line. And the way that I do that is figure out, or the closest to, I'm sorry, the point on the original line that's closest to the origin, closest to the point. And the way that I do that is figuring out where the line and its perpendicular intersect each other. So I'm going to write out my original equation. Y equals 3x plus 3. And now I'm going to set these equal to each other because y equals this and y equals that. So I can substitute one of these in for y. Negative 1/3 x equals 3x plus 3. This is going to be way easier if I just multiply everything by 3. So I'm going to do that right away. That's going to be negative x equals 9x plus 9. I'm going to subtract 9x from both sides. That's going to give me negative 10x equals 9. But it makes sense because if I graph this out, I see that my student lives on this street over here. So his x value is going to be negative compared to the school, which is at the origin. So everything is going good. This means that x is going to equal negative 9 over 10. And if x equals negative 9 over 10, I can plug that into my first equation. X equals negative 9 over 10. 1/3 of negative 9, negative 1/3 times negative 9 over 10 gives me a y of 9 over 30, which is the same as, let's see, 3/10. So my XY coordinate for where this student lives, or what the closest point between the school and the street is negative 9/10, comma, 3/10. Now, this is going to be a bear of a distance formula, but I have to use the distance formula between the origin and the student's location. The only good thing about this is my origin is 0, so it's going to make the distance formula a little easy. D squared equals, and then it's going to be x2 minus x1 squared. Well, x1 is just 0, so it's going to be negative 9/10 squared plus, and then y2 minus y1, but it's just going to be 3/10 squared. Okay, now we're hoping for the student's sake that this number is greater than 2 so that he can ride the bus. Let's see. 9/10 squared plus 3/10 squared. So it's negative 9 over 10 squared, but technically it doesn't matter, right? Because negative, we can plug it in, right? But when I square it, it's going to become positive anyway. 9/10 squared plus 3/10 squared. And then I need to take the square root of that to get the distance. And the student lives 0.94 miles away. looks like this student is going to be walking. Uh, he cannot ride the bus. All right, that is how you solve these types of problems. Lots of steps. Get at it.